All right, so does anybody have any questions here? Some of those shapes were pretty hard, so I want to get to them. Go. If each slice costs $0.25 to make and she sells 8 for $1.25, how much money will she raise? Well, if there's 8 pies, right? So you're cutting it into 6 equal slices, right? So that means there'll be a total of how many pieces?
Or 48.
Right. So to me, that was just 48 times $1.25, right?
Yes.
So tell me what that is. So she's going to make $60, but it's each slice. Well, I should have not even done that. If each slice costs 25 cents, then she sells it for $1.25. She's going to make what? $1 per slice, right? And you said there were how many slices? 48, right? So she makes 48 bucks. You agree with that? All right, someone else. Tell me. Yeah, me. Good job. Let's look at 30. Yeah, these are important, guys. All right, hopefully you spend a little time. All right. All right, Luna is organizing a banquet for Honor Society, and she needs 13 tablecloths for the round tables in the hall. The area of each table is approximately 29.27 square feet. She can rent tablecloths for $16 each, or she can make them herself. Her local fabric store carries the 3 different bolts of suitable fabric. The standard bolt is 60 inches wide and 100 yards long and costs $75. The wide bolt is 81 inches wide, 25 yards long, and costs $125. The extra wide, blah, 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 blah. Each tablecloth should cover the table with 9 inches of overhang. Yeah, that's a lot, right? All right, so she has 13 tablecloths. And the area of each table is 29.27 square feet, right? Now, we have to figure out, if I'm not mistaken, we have to figure out what the radius is, correct? Because we need to have it overhang by how much? 9 inches. Does everybody agree? So if the area of each table is 29.27, area equals pi r squared, correct? So I need some help, guys. 29.27 divided by pi equals r squared. So what's the radius approximately? Tell me. 3.052. All right. And that would be what? Feet, correct? Does that make sense? Are we okay with that? Now, here's the issue I just noticed. Each tablecloth should cover the table with 9-inch overhang. So right now I have this in what? Feet, right? So I can't just add 9 inches. I'm going to have to add what? How much? That's all right. It doesn't matter. Add 0.75. So take your calculator, or, you know, tell me the radius of your, the radius of the new table would be 3.803. Now try to just keep that in your calculator. All right. So that's the radius of the tablecloth that will be perfect for your table. Does everybody agree with that? All right, so she needs what now? To figure out the area, right? So we got to do area equals pi r squared again. So do that. And tell me what that was. Say it again. 45.412. That's good. All right, so that's the area of each one. Now, I'm going to need how many tablecloths? So I multiply that by 13, right? And so what do we get? $590.47, whatever I heard. And that's square feet, right? So she can rent tablecloths for $16 each, or she can make them herself. Her local fabric store carries 3 different. The standard is 60 inches wide and oh, this is annoying. I agree with you guys on this. All right. Wow. Yeah, because first of all, yeah, I should have just crossed this one out. But again, we'll just discuss it real quick. First of all, if something, when you make something into a rectangle, if you make something into a rectangle, which is what the fabric is, does everybody agree with that? Does this area, if I have 590.47 square feet here, and this is 600 square feet, am I good? Am I good on that? Somebody said yes confidently. Somebody tell us what the problem is. Tell me. That's exactly right. You have to cut circles out. And when you cut circles from rectangles, there's always going to be what? Yeah, there's always going to be some waste. Does that make sense? All right. So in this case right here, I should have read this question more clearly. I don't think it's necessary. But again, so that's the first thing. That's what I think they mean by what assumptions do you need to make, right? So again, I don't mind if we stop here. All right. That was a little bit too much in depth, I think. All right. So let's stop there. Tell me about something else now. What? 24. Okay, yeah, this should be relatively easy. These are always on the ERBs too. Right, so find the area of each sector and the degree measure of each intercepted arc if the radius of the circle is 1. Well, my country represents 10%, right? So that's just what? That's just 36 degrees. You with me on that? But more importantly, we don't even need that, right? Because 10% means 10% of what? Well, even better than that. 10% of the what? Area. Thank you, Sam. It's just 10% of the area. So I can find the area, which is pi, by the way. Does everybody agree with that? And that way we can say country is going to be pi over what? Pi over 10. Does that make any sense? You can say no. Okay, so country, right? Do you understand the area of the circle is pi?
Yeah.
All right, so country takes up 10% of the circle. And 10% is 1/10. You see what I'm saying? So here we have classical as 2%. So I just take pi and multiply it by what? 0.02. Rap, 0.48 times pi. Rock and roll, 0.26 times pi. Alternative, 0.14 times pi. Does that make sense now? All right. Now, if you want to figure out the degree of each one, that's when you do 0.48 times what? 360. 0.02 times 360. That'll tell you the degrees. All right. Does anybody else have any questions on 24? Is that satisfactory? Sam.
So I do this with like rock and roll. I would find out and I would divide that by 360.
So now, Sam, listen, because you are brilliant, I want you to hear what you just said, and then you can tell me if you understand what I'm saying. So you found 26% of 360. What is that? So 93.6. Then you divided it by 360, and then you multiplied it by pi, right? What is 93.6 divided by 360? Shh. That is exactly correct. You see what I'm saying now, right? So this right here is an excellent formula, but what I'm trying to get you to understand is 93.6 divided by 360 was we already knew that was 0.26. You see what I'm saying? That's why I think it's kind of silly that they're asking you for the central angle if they gave you the percentage. All right, makes sense, right? All righty, somebody else. Go. Say it again. Ooh, this was actually an SAT problem. The age of living tree can be determined by multiplying the diameter of the tree by the growth factor or the growth rate. What is the diameter of a live oak tree with a circumference of 36 feet? If the growth factor of a live oak is 130, what is the age of the tree? The age can be determined by multiplying the diameter of the tree times the growth factor. If the growth factor of a live oak is 130, right? So that's 130. And the circumference is 36 feet, right? If the circumference is 36 feet, we have to figure out what the diameter is, right? So it's just 36 divided by pi. Do you agree with that? So then the age of the tree is going to be 36 divided by pi times 130. Does that make sense? All right. So again, to me, it was just about writing out the formula. All right, you guys don't have any questions on 32, 33, 34. Those were great questions. Tell me. All right, let's look at 28. Yeah, again, couple people asked me about this. This is just about working backwards, right? So area equals pi r squared times n divided by 360. So now we're just erasing this a and putting 94. And then we don't know what r is. Oh, yeah, we do. We know r is 14. So I throw a 14 right here. Am I okay with that?
Yeah.
And now I'm just solving for n, right? So take 94 divided by 14 divided by, well, I'm sorry, 94 divided by 14 squared divided by pi times 360. (94) divided by 14 squared divided by pi times 360. Now look, does everybody understand what I just said right there? Make sure you're understanding me. Right, you can't do 94 divided by 14 squared times pi. Does everybody agree with that? Hello? Right? Now, if you wanted to, you could say 94 divided by parentheses 14 squared pi, close parentheses, times 360. That's the other way you can do it on your calculator. But I'm trying to show you how your calculator will do order of operation. All right, so make sure that's good. Does that make sense now, Bo? Did you do it? Did you want to check?
Yeah.
What did you get? Anybody else get that? 50, about 54 degrees, somewhere around there. All right, I'm happy with that. All right, someone else. Good, William. This one, 29. All right, so now it's the same kind of process. Again, I really think it's just a calculator. All right, so here we go. 128 equals pi x squared 152 divided by 360. So now, if you can write that, then you just work backwards. So everybody on your calculator would do 128 divided by pi times 360 divided by 152 equals, and then what? Square root of the answer. Does that make sense?
Yeah.
Just working backwards. And then what do we get for x? What's the radius? About 9.823, someone's telling me. Anybody have any issues with that? Man, I'm mad. 30. I hate that. Okay. Somebody else now. Let's go. Yeah, these are all really good problems. Okay, so can you tell me what this angle is right here? Yay, very smart. That is 90. So if this is 5 radical 2, then this whole thing is what? Somebody help her. 10. Why is it 10? Right, exactly. You went from the 45 to the hypotenuse, right? So you multiply by radical 2. So that whole thing becomes 10. Do you agree with that? All right. So that means the radius is how much? 5. Beautiful. All right. The radius is 5. So the area of the circle would just be what? 25 pi, right? And then we're subtracting out the area of the triangle, which is 1/2 5 radical 2 times 5 radical 2. You agree with that? So then half of cancels. So did anybody else get 25 pi minus 25? Is that right? Guys? Anybody else? Any issues on that? All right, all those problems are pretty nice. 35. Yeah, that one's kind of easy, right? The reason it's kind of easy because the area of the rectangle minus 2 circles. Do you agree? And again, I like doing these because these are the ones that are on the SATs and ACTs a lot of times. So what's the area of the rectangle? 50. All right. So how much is it here to here? What would that be? 5. So what's the radius? 2.5. So it's 50 minus 2 pi 2.5 squared. Why is that? Because there's 2 circles. Thank you very much. This right here represents the area of what? 1 circle. This 2 is because they're 2 equal circles. How much was it? No, I want it in terms of pi, though. I want you to leave it as 50 minus 25 over 2, 12.5 pi. Is that right? Somebody do 2.5 squared times 2 and tell me if it's 12.5. Yeah, 12.5 pi. And then, of course, we just say centimeters squared. Anybody else? Nobody? All right, hopefully you spent some time on that. All right, very, very important information dealing with circles. Nobody else? All right, that's good. All right, let's go ahead and jump in today's lesson. Area of a regular polygon, 10-4. And I did some irregular shapes, which should be pretty easy. All right, I'm going to tell you what the geometry book says, and then I don't like the way they teach it, so I'm going to show you. All right. So here is a regular pentagon. All right, now just look up here for a second. You don't have to write anything down. All right, just watch. It's super duper, super easy. All right, the formula for area of a regular polygon is said to be area equals 1/2 perimeter times the apothem. What in the world's the apothem? The apothem is, wow, it's exactly right. It's the perpendicular distance from the center to the side of the polygon. That's called the apothem. Never knew what an apothem was till I read these new geometry books. All right. Part of the reason why I didn't know what that was because that's not how I learned it. All right. I'm going to show you how I learned it, and then you can see hopefully how much easier that is than trying to remember one more formula. All right. This is a regular pentagon. So what did I do? I just constructed this here to here. I drew from here to here. And what is true about all of these triangles that I'm drawing? They are congruent. All right. They are congruent. Does everybody see that? Everybody with me? So how many triangles are there? So 5 times 1/2 base times height. Well, this is the base, correct? If I multiply 5 times the base, what is that? No. What is that called? 5 times the base. The perimeter. Whoever said that, pat yourself on the back. You are brilliant. It is the perimeter. Now look, all I'm just trying to show you is how the formula works, right? 5 times the base would be the perimeter, right? Now, the apothem, for whatever reason, is the height of each what? The height of each triangle. All right, is everybody with me on this? So to me, this means nothing. I would never remember that. All right, what's important is that every time you see a polygon, you just break it down into triangles. All right, that's how simple this section is. All right, the only difficult part here is that we're going to have to use some trig. All right, but again, that's easy because we're smart. All right, so again, let's jump down here. All right, so question number 1. Area equals, how many triangles are there going to be? 6. So here we go. There are 6 triangles. So I want everybody to write 6 times 1/2 base times height. Now, why is this one really easy? Because it gives you the base and the, yes. So 6 times 1/2 times 11.5 times 9.96. Oh my goodness. So tell me that again. 343.62. I hate to say it, I think I made a mistake.
Oh, no.
All right, here we go. Oh, not on the formula, not on the math, but just on this worksheet. Okay. So 343.62 yards squared. Is everybody with me on this? All right. Now, number 2. Tell me. 1/2, or not 1/2, but how many triangles are there? not sure I trust you. Yeah, 7. So 7 times 1/2. What's the base? And what's the height? Yeah, 9.34. All right. So go ahead, do the calculations on that. And then we'll call it square inches. All right. Now, look how dumb number 3 is. All right, they're trying to teach you that using a formula, all right, because a square is a regular polygon. But instead of doing the 1/2 perimeter times apothem, we should just be able to say it's what? Yeah, that's where I have my problem with that. So 18 squared is obviously 324 square feet. And let's move on. All right. Now, what we're going to do now is I'm going to change things up. All right. So I want everyone to take their little white out here. That's why I said I made a mistake. Just erase that. All right, that right there. All right. And then what I want you to do is I want you to erase the 3.6 right here. Then I want you to erase this 8 right here, and I want to erase this 6.93. All right, and because I made a mistake, I will allow us not to have homework. All right. So just stay with me, all right? And then I'm going to draw from here to here, and I want you to put a 10 right there. I'm just gonna, sorry, I really made a big mistake here. What? Oh my goodness. Here we are. As soon as we finish this. All right, so I want that to be like 5. All right, here we go. So we have 6 problems to do. All right, then we'll call it a day.
No.
Well, 6 of these problems. All right, everybody got that written down?
No.
All right, and it's okay because I'm just going to blow up on them anyway. All right, and then you can see as we're going. All right, so I'm going to everybody take a look at number 4. All right, everybody take a look at number 4. And this is obviously a what? This is obviously a pentagon. So the first thing we're going to do is we're going to write A equals 5 times 1/2. What's the base? 10.3. Anybody got a problem so far? And then I'm looking for the what? I'm missing the height. All right, I'm missing the height. All right, so here's what we do. All right, we're going to draw one of the triangles. And then this is 10.3. Does everybody agree with that? Now, what I want to do is I want someone to tell me quickly what the angle here is. What is this angle? What? What does that angle measure? No. Think first. Tell us, Harris. Slow down on that one. 72 degrees. That is in fact 72 degrees. Right. How do I know that? Because it's just 360 divided by 5. There are 5 sides. All right. Now, what I'm missing is the height. So now I'm going to draw this perpendicular down here. And when I draw that perpendicular, what does it do to that 72 degrees? Cuts it in half. All right. So now what I'm going to do is take my little eraser right here, and I'm going to put 36 degrees in there. Okay. And now because that's 36 degrees, the 10.3 is also what? It would be what? 5.15. Now I can find the height. So someone tell me the formula I'm going to use to find the height. Tell me. Tangent of 36 equals. Thank you so much. That is exactly correct. All right. Tangent is opposite over adjacent. All right. Tangent is opposite over adjacent. So now my height is 5.15 divided by the tangent of 36. Come on, guys. So now you just keep that into your calculator and it goes right there. So now you hit times 10.3 divided by 2 and then times by 5. 182 point what? And then we'll call it square feet. All right. Again, this stuff is easy if you remember the trig. Now, I'm trying to figure out, were they correct of the height there? Did we get that as the height? Hello? Was that the same answer we got? All right, so they actually did it correctly. All right, here we go. What?
Why do you like switch like the
How did I switch? Say that again.
Because you multiply the H and then you divide the 10.
Yeah, that's exactly correct. If that's what you're asking. Look, I multiply this by H and divided that by tangent 36. You see what I'm saying? I'm trying to isolate the H. I'm trying to get H by itself. Do you agree with that? So I just moved H over and then divided. That's the quickest way. Or if you want, you can just make a proportion if you're confused and just cross multiply. All right, so here we go. Let's check out number 5, please. All right, so now again, they give us the what this time? They give us the height. So I need someone to tell me, how many sides is that? 8. So I have area equals 8 times 1/2. My base is unknown, but my height is what? 4.35. Come on now, get in the game. See if you can play. All right, this is 4.35. All right, this is 4.35. So now I want to know, how do I figure out what this angle is right here? How did you get that this time? Yes, 360 divided by 8, but I'm not interested in that angle. I then have to do what? Right, so this angle right here is 22.5 degrees. It's 22.5 degrees. Karina, you all right? All right, tell me. All right. I need this, X. What is it? What trig? Say it again. Tangent of what? Is equal to, say it.
X over
4.35. Thank you. So now this time, all I have to do is move the 4.35 over, right? So X is equal to, somebody tell me. Okay, whatever that is on your calculator, double check and make sure you have that. Yes, that's what we have. However, we have a problem here. What's the problem? That's this distance from here to here. Is that the base? Yeah, now multiply by 2. 3.1604, something like that, you're telling me?
3.6.
Oh, 3.6, you said. Okay. Now, you take that into your calculator, right? Still there. And now you're plugging that answer into here. Multiply it all out, please. How much? Now, again, does everybody see if you round, you're gonna have different answers? Does everybody agree with me? Right? So somewhere around there, and again, it's square yards. Square yards. All right, so good review of our trig. All right, here we go. Now, this one I want everybody to take a look at is called a what? It's called a hexagon, I do believe. And the hexagon is special. Why is the hexagon special? Yes, thank you so much. All right. So they're all equilateral. So this is 10 and this is 10. All right, now this one's easier because we don't have to use our calculator. All right, so the area is equal to, how many triangles are there? So 6 times 1/2. What's the base? Okay, now who's been paying attention? What's the height? No! Thank you. That's what I was thinking. I didn't want to say it, but that's what I was thinking. What is it? 5 radical 3. We are brilliant. 5 radical 3. So, with that being said, the correct answer should be 150 radical 3, and we'll just call it feet, square feet. All right. When you get a 30, 60, 90, you can give me the exact answer. Everything else is an approximation. Yes, sir. How did I know it was equilateral? That's a very good question. All right. So first of all, do you agree automatically this is 60? Right? Because we just did 360 divided by 6, right? Now the key thing is to remember that this is an isosceles triangle. Right? So that means this has to equal this. You agree with that? And then if we do that, then that forces that to be 60. All right? So anybody have any issues with that? Yes, 5 radical 3 is the height. Do you want me to show you how? Shh, no one's asking you. Yeah, because remember, when you drop this down, it cuts this in half, and then our formula was, that's just the leg times radical 3. Again, guys, I'm just saying all of this is good information and good review for your upcoming, some of you guys will be getting into your private schools. They're going to be asking you questions. You got to know. All right. Here we go. Over here now. Number 7. What do I have? What is it? Are you sure? 8. Okay, here we go. So area equals 8 times 1/2. What's the base? 5, right? Now, here we go again. Because it's an octagon. Yeah, we already did this one. Thank you, Davis. And then, so set it up for me. Tangent of 22.5 is equal to what? You are amazing. And so x equals what? No. I need the x equals 2.5 divided by tangent of 22.5, which is? All right, whatever. Keep that on your calculator. And when you keep that on the calculator, just multiply that out. Say it again. And then we'll just call it inches squared, something like that. Anybody else have that? I don't need that. Anybody else? Anybody else? Anybody else? All right, here we go. Now, the reason why I left this one alone right here, 6 feet, is because this is just a very common problem All right. And again, they have 1/2 perimeter. We don't do that. That's just a triangle. It's an equilateral triangle. So area equals 1/2. What's the base? Now, don't hesitate. What's the height? What? 3 radical 3. The height is 3 radical 3. Come on, if you forgot, remember. Does anybody have any issues with why it's 3 radical 3? We knew that because we just did that in the hexagon. We just did that in the hexagon. What? What?
I got what you got, but the decimal.
It's just the way you, most of the time, it's the way you're typing it in on the calculator. Right? Some people are not using exact, some people are. So if you got somewhere around 120.7, I'm not arguing with you.
I got 12.07.
The final answer is 12?
I got, yeah, just the decimal was between the 2 and 0.
Well, you need to double check that. 8 times 1/2 times 5 times 6.03. Unless you didn't get something like the 8 or the 1/2 or the 5 or 6.03. Which one did you not get? Shh, come on, let him, he's trying to learn something now. Somebody help him. Drew, what, you got it now?
Yeah, I didn't.
You okay now, right? Okay, so here we go. So this over here, I want everybody just to tell me that's what? 9 radical 3 square feet. You agree with this? What? What?
Don't you also have to divide it by 100 times it by 100 sides?
No, because it's one triangle, right? It's one triangle. All right, that's what's so silly. They want me to use a 1/2 perimeter times the apothem, right? It makes no sense. All right, what? Because we've done it 100 times. Draw this down. If you don't know, this is 3 radical 3. Because it's a 30, 60, 90 triangle. You with me on that? You have to remember the equilateral triangles in the hexagon, all right? You can use that formula for a hexagon and for a triangle. That's it. All right, now the hard one. All right, now why do I say this one's hard? Because we don't have what? The base or the what? We don't have the base or the height. All right, so come on now. All right, what's the central angle? 72. So when I draw, it's going to be 36. All right, 36 degrees. Now I need to find the height. So how do I find the height for that? Someone, come on, someone else, get involved. Same people telling me the same stuff all day long. What, Sam? Thank you. Is equal to, is it 5 over h or h over 5? See, they're messing with you, Sam. H over 5. Because remember, it's the adjacent over the hypotenuse. Adjacent over hypotenuse. Do you agree with me? And 5 is definitely the hypotenuse. Do you agree with this? Again, this is a good review problem, all right? That's it. Good review. All right, so now we know the height is 5 times cosine 36. So now, how many triangles are we dealing with? So it's 5 times 1/2. I still don't know what the base is, but I know the height is that answer, right? Now listen, do me a favor. Hit the store as X. Store as X, and that'll put it in your X. STO, it's on your calculator. Hit store as X. All right, then hit enter. Then hit the X button and hit enter again, and what happens? That's the number, right? That's what I'm showing you. All right, so what did you say it was approximately? 4.04, whatever. All right, now I need the what? I need the base, and I'm going to call this B. But you have to remember that's only what? Half of the base. All right, now for me personally, I would just do, instead of trig, the Pythagorean theorem. I would just do on my calculator 25 minus the answer squared, square root of that answer. So this was 2.9 what? And then multiply that by 2. And that will be the whole base. Now you're allowed to ask me a question if you're not sure about what I'm saying on that. Come on now. Tell me, Reed. Yeah. Okay, so do you understand now that I have this piece of the puzzle, the height, right? And I have the hypotenuse. So I'm doing a squared plus b squared equals c squared, right? So 25 is 5 squared minus the x squared that's on your calculator equals, and then square root that. That is half the base. Do you agree with me on that? Because that is half the base, multiply that by 2, and that will give me the full base. Now you found the exact answer. There's been no approximation. So now that answer that you have on your calculator, is everybody with me, goes right here. Does everybody agree? Times 5 times 0.5 times the stored x value. Hit x and then hit equal, and you should have the answer. Area equals. Yay, 59 point, what about? 441. All right, and then whatever, units squared. All right, just remember we're doing area. All right, what time's the bell ring? All right, so that's good for me. All right, so now AC, because you came in late, I don't think it's real hard. You can skip like the first 5 or 6 minutes of I really messed up on one of the word problems. Number 30, was that what it was? Yeah, if I start talking about 30, just fast forward if you're gonna listen to it. All right, but again, basically for you right now, listen to me. All of these problems are broken down into individual triangles to find the area of a polygon. All right, and you use trig. And I made the worksheet too easy, so I changed some sides. All right, so here we go. Now I want everybody to go to the next page real quick. All right, now they're calling these area of irregular polygons. But again, this is not going to be a problem for us. All right. Now I said I was going to give you a break, so here is your break. All right, we're going to try to find the area of number 1. Everybody find the area of number 1. And if you get it right, we don't have to do any more. Shh, shh, shh. And you can't look at the bottom of the page, Harris.
Oh, I'm not. I'm not.
I'm watching. You don't even know where to start. How about there's a trapezoid right there?
No, there's a square. There's a square. There's a square. There's a square.
I'm in the square, that's why.
Stop. All right, that's it. I can tell you already we're going to have to do the whole worksheet.
Guys, I'll do the square.
Just scroll down. I already did the square.
Morty, no more slacking.
I'm doing my
Doing the least possible amount you can. It's the story of your life.
Yeah, you did. Because you were playing games yesterday.
Thank you.
Games.
All right, who's got it?
How?
Because he's looked at the answer at the bottom of the page. That's how.
That's how. That's how.
Shh.
I got it. I'm hot on the trail.
All right, I knew you would do it, Harris. You're my go-to guy.
I got the trapezoid.
I got the square.
Come on, girls.
Yeah, they're not as good.
Oh, did you hear that?
I got the trapezoid, it's 6.75.
No, it's not.
What are you talking?
It's like 33.
What is he talking
You
about?
can multiply it?
Oh,
Oh my god. Would you add the base and then
Drew, you used to be way up there, Drew. You used to be one of my top man. You used to say the area of that trapezoid is 3. What are you doing, man?
I got 90.3.
Uh-oh, we have it. Lorenzo. Say it again, Lorenzo.
90.34.
All right, 90.34. All right, if I look at the answer and that's incorrect, we're doing the whole. Wow. The girls are not trusting you, Lorenzo. Wow. That was pretty harsh. That was pretty harsh.
That's right. I trust him. Yeah, I trust him.
90.34.
Wait, Lorenzo,
I know
Right.
I trust you. I trust you.
I trust him.
I'm kind of feeling Lorenzo's answer.
Morty, you would know an answer if it slapped you in the face. Lorenzo, now you have to tell me how you got that. Go.
All right, so
Shh, shh. I'm listening.
the top part of the square is 5.9, and I did 2.4 plus 5.9 plus 2. And that's the second base of the trapezoid.
You are amazing.
And then I forget what that is. And then it's that plus 3.2 divided by 2 times 5.
You are so far. Okay, you might save
That
us.
area of the.
Okay. All right. Now what, Smarty
And
Pants?
the trapezoid on the left is just 5.9 plus 4 divided by 2 times 2.4.
You are brilliant so far.
11.88.
Blah, blah. Go.
And then the square is just not that hard.
I got it.
That.
Oh, you're insulting some people in here by saying it's not so
just
hard.
5.9
Wow.
times 5.9.
Drew's over here saying 3, so don't.
Got it.
These guys hurt feelings now.
I got 96.
Go. And now what?
And then the thing on the right,
That would be a what?
trapezoid, the left side, or the second base is 5.9
All
for
right.
the square. And then it's just that plus 4 divided by 2 times, or just that times.
Ooh. You guys, I saw y'all cheating down there. I saw y'all cheating down there.
I got it.
You got it?
Yeah.
Harris, no one
So
believes
did
you.
I.
All right.
Sound.
So I could go with number 4, but
But
all right.
Kids just have fun at work day.
It is. I'm having fun.
well, too bad. We're not
All right. The end for today, guys.
Guys, you're not done with
Good
work.
job. Good job. Good job.